So if you look at these molecules, you'll notice some similarities and small differences. They all contain a total of 4 carbon atoms along with 1 double bond. So they'll all have the same molecular formula. So there's some type of isomer. Isomers simply indicate molecules that have the same formula, but something about them is different. So in other words, they have the same type and number of atoms, but something is different about the molecules. You have structural or constitutional isomers, which indicate that the atoms are arranged differently, so as a result, they'll have different names. But you also have stereoisomers, which means that the atoms are the same, they're connected the same, but their three-dimensional arrangements are different. So if we look at these 3 molecules, so we've already gone through and we learned how to name alkenes. We can see we have 4 carbon atoms as our parent chain. We have 1 double bond, so we know that each molecule represents butene. That's the same for all of them. 4 carbon atoms, 1 double bond. Remember, we have to indicate where that double bond is located. For the first molecule, if I count from left to right, 1, 2 is where it starts. Counting from right to left, 1, 2 is where it starts. So we get a tie. So it doesn't matter which direction we count. It still represents 2 butene. Same thing for the second structure. 1, 2 from the left or 1, 2 from the right. So again, we have 2 butene. The last one, 1, 2, 3 from the left versus 1 from the right. So if we don't have a tie, we want the lowest number, which would be 1. So although all of these represent butene, meaning they have the same formula, something about each molecule is different from the others. The 1-butene, different name. The atoms are arranged differently. So this would be the structural isomer of those. These have the same name, which you'll see in stereoisomers. Stereoisomers, same name because the atoms are connected differently, but something about it is slightly different. And so if we look at what's different about those 2 molecules, we have our double bond located between carbons 2 and 3. We know that carbon always wants to form 4 bonds. So if we look at this second carbon, it has 1, 2, 3 bonds. So remember, we have to count the double bond twice because there are 2 bonds between carbons 2 and 3. So this carbon, we can see 3 bonds, so we know that there's 1 bond that we do not see. Where this double bond is located, there's a carbon that is pointing in a downward position, so that means that there's going to be a hydrogen pointing in an upward position. If you already have something down, you can't put anything else there. It has to go in the opposite direction. Remember, that's what Vesper tells us, the valence shell electron pair repulsion theory. The electrons want to be as far apart from one another as possible. Since I already have electrons in this bond, there's this entire open space here where electrons will go in the opposite direction. Same thing here. Because I already have those 2 bonds, that 1, so I have 1 hydrogen. If I looked at that carbon, I can see that it was pointing in an upward position. And so I had a carbon pointing downward, I had a carbon pointing upward. Or I could have looked at my hydrogen. I had a hydrogen up, I had a hydrogen down. So when you're looking at stereoisomers, you want to look at with respect to, in this case, of the alkene, with respect to the double bond. I have carbon atoms pointing on opposite directions of their double bond. Or I have hydrogen atoms directed opposite sides of the double bond. This represents what we call a trans isomer. Trans just means opposite sides. If you have a hard time seeing that, you can turn your paper sideways until your double bond has somewhat of a flattened appearance. Now that it's flat, I can see I have something down, I have something up. I have something up, I have something down. Opposite sides, so it becomes trans. Same thing with the next molecule. Where my double bond is located at, that carbon has 3 bonds already. This carbon is pointing downward. So that means my hydrogen is going to point up. Carbon on the opposite side is pointing downward. So this hydrogen will also point up. Now both carbon atoms are pointing in the same direction. Or I can look at both hydrogen atoms, which are also pointing in the same direction. So this would represent a cis isomer. Cis and trans are stereoisomers. So those molecules have the same name, 2-butene, but what's different about them is how those groups are arranged around the double bond. Cis means same side, trans means opposite side. In order to fully name this molecule, you would simply add trans or cis to the very beginning. This indicates exactly how these molecules are arranged. So not only do we have 4 carbon atoms in a continuous chain with a double bond between carbons 2 or 3, for this molecule, I have my carbon atoms that are coming off of that double bond going in opposite directions, whereas this molecule, they're the same. For this one butene, I can't indicate cis or trans, because if we notice, so with carbon 2, there was a carbon going up, my double bond pointing upward, so that means that my hydrogen will point down. But then for carbon 1, I don't have another carbon, I only have those 2 hydrogen atoms. So I have a hydrogen up, I have a hydrogen down. So while this molecule has cis hydrogens, at the same time it also has trans. And so I can't indicate cis or trans, so it will simply be named 1-butene. 1-butene is the structural isomer of 2-butene. Cis-2-butene is the stereoisomer of trans-2-butene. And so these are different types of isomers. When you're naming alkenes, still go through the rules of naming that molecule. So identify your parent chain, identify any substituents, number the parent chain so that your functional group has the lowest number. Use that same numbering system to identify where the substituents are located. Put everything together, putting your substituents in alphabetical order, followed by the parent chain. But the extra step, if you can indicate what type of stereoisomer is present, you will add that to the very beginning of the name. So the normal or the original rules that you learned will simply tell us 2-butene or 1-butene. But now that you know how to distinguish between cis and trans, if you can indicate which one is present, we have to add that to the very beginning of the name to get full credit and to fully name that molecule.